Hello everyone, my name is Alex, and welcome to the first episode of how to make a Minecraft 2D side-scrolling platformer in Java. So this is gonna be like any other Minecraft game. Well, actually, it's gonna be like Minecraft, but it's gonna be 2D platformer. And just to say in the beginning here, I've actually never really made something that's gonna look exactly like Minecraft. I only made things that's looking a little bit like Minecraft, but I promise you it's gonna be fine. I know exactly what I'm doing. So that's that. So it's basically gonna be you have your character, you can move around in the side-scrolling world, and what you do is you move around, you collect resources, you try to survive, and I'm probably gonna add some monsters in the last episode, some easy monsters. We're gonna learn how to import images, and everything is gonna be about optimization in this tutorial. So if you don't know about good game loops and optimization, how you create things that's good, then then watch this anyway. If you wouldn't like to make a Minecraft game, but at least the first episode is gonna be very good for you guys then. But anyway, we're just gonna start right off here. We're gonna create a new project. We're gonna name this project Client. Now, I want to make sure that you can see what I'm doing. I'm gonna create this in the Java SE Second Edition 1.6, the Java Runtime Environment 1.6. Why am I creating this in the JRE6? Well, I'm creating this in the JRE6 because there's so many people that haven't updated their Javas yet. So I'm gonna create this in the Java 1.6. I've been having problems with this before, and people complaining about why are you creating this in the Java 7 then? Well, because it's the newest one, it's the best one. Come on, and I'm just gonna go for the Java 1.6. So that's why I'm creating it in Java 1.6. Let's see if my commentary skills can can make me survive for 2 hours, since these are gonna be like 2 hour. It's gonna be 3 episodes, which I didn't really tell you before, but that's that. Now we should have gone through all the details and information. So I'm now creating the client. I can open it up like usual, and we've got warning. Build. Oh yeah, it wants me to use the JRE7, of course, but I'm not going to do that. So let's create a new Java class. Actually, before creating that, we want to create a package. Now, packages are basically just used like you can import stuff and you just make a stronger program. I'm not really used to packages, but we're going to create one for the sake of this tutorial. So net Ulixava is normally your website address. Backwards, net Ulixava is the same with Android. It's creating in exactly the same way. So I'm going to go with net Ulixava and then the game name, which is going to be Minecraft Platformer. So that's the way you normally do packages, and Eclipse is gonna sort most of the things out for you. So when I click at this package here, now this is in the source folder, and the source folder is containing things like your sources, so your code. For people that's new to Java, I actually recommend you to watch my beginners tutorials before doing this, but it's fine. It's fine. So I want to create a new Java class, and what I want to do in here is I want to type in component. Now, a component is actually an existing class in Java AWT component, but we're not gonna use that component in any ways. But if we would like to use it at a later point, we could just import it and type the full thing when extending things and stuff. For you guys that don't know what extending is, then it's gonna get much clearer to you while doing this tutorial. So, alright, so we started up our class. Now, there are a few things we want to create before actually doing this. Now, we are going to make this both an applet, which is for the web, so you can put it in the web, and we're also gonna make this we're gonna be able to have it in the as a normal window like this. And there are a few so to say problems with having it in a window if you're using an applet, but it's gonna get a lot clearer as well as quick as you start understanding this. So we're just gonna start right off with extending this with the applet, which is from the imported from the import java.applet. And or importing things is basically inheriting another thing. Oh wait, not applets. That applet. So it's basically inheriting this applet, these applet methods. It's basically a lot of classes you can call and create objects out of. When it's called the applet, and it's for web and devices or web and stuff. So what we want to do in here is, first of all, we want to create the constructor, public component, and what this is going to do is this component thing. It's going to be setting sizes and stuff. Now we're also going to have a few other things that we want to have if this is an applet. So we want to have a start method, public void stop method, and all these are applet methods. So you're going to see that these little green things here, that means that we're actually overriding the start and the stop method. And as I said before, both of them are from the applet method. So if we go down here, we're going to create the public static void main string args. This is the main method. This is very basic Java. You should know this. That whenever you start a program, it goes here. If it's not an applet, then it goes to the start method over here. Actually, gonna right click here and show the line numbers. Alright, so what we want to do next is, since this right now we want to have this as a window like this, because we're not going to develop for applets right now. So what we want to do here is, in the main method here, what we want to do is we want to type in, or we want to create a new object out of this method. So component now equals a new component. So now what we're doing here is we're creating a new object out of this component method, so we can actually go ahead and use it for different things. So down here we're going to create a new JFrame. We're going to call it frame equals new JFrame, and we haven't imported that yet. That's also an import. That's basically the easy way of opening up a window. We could have used the Java AWT windows, but it would just take a lot more time. So frame dot first of all, we want to do frame dot add component. This is adding the applet onto our JFrame. You can add applets onto JFrames, and it's a very good way to have it both used in the web and other things, so like both the web and the as a normal window popping up. So after doing the frame.add, now the component, when it's created like this, it's gonna jump up here and see what's inside here. So this is where we're gonna set the size of this window. And so we're gonna create a new public dimension. Gonna call it size equals new dimension. Now what dimension is it's something that takes the parameters, and it's imported from the Java AWT, else we're gonna get errors. So what a dimension is, it holds a width and a height, and it's very, very good for setting window sizes. And if we make this static like this, which we're gonna do, we can even access it from other classes. Public means that other classes can see it, and it's static, so other classes can use it. And it's kind of self-explanatory. You guys are gonna understand this as the series goes on. But in the size here, we want to find a nice size. So I'm gonna go with 700 times 550. So comma 550. This is the width and this is the height. So we're basically creating a new object out of this size. And these two things here, 700 and 550, as you can see in the constructor here, there's also a constructor of the dimension method. This dimension method, and it's actually taking two parameters like this in width and height. This is not nothing you're gonna do. I'm just gonna show you, and that means that you need to give it objects or things like this. But it also has, as you can see, if we remove this, we're actually not getting any errors at all. That's because it has two different constructors, which goes to either if you want to put these in, then it's fine, but if you don't want to, it's just gonna be 0 0 by default. So we're gonna have 700 by 550, and we're gonna set the size in here to size like that, and also set the preferred size, which is for the applet, and the other one is for the window. We could actually go without this, since yeah, we can go without this since we're actually setting the size of the applet, and the size of the applet is gonna be what the size of the frame is. So what we want to type in here is frame.pack. Now you guys are probably gonna be very unfamiliar with the pack method. What the pack method basically is for the frame, we are doing frame.pack. As you can see, we've actually added the component. And the component have got its own size, which is 700 by 550. So in the frame.pack method here, or in the frame.pack, what it's doing is it's setting the same size as all the components that's on the frame. So basically setting it to be 700 by 550. So that's pretty much how it works. So once we've packed it, we can do other things like setting the visibility and stuff. But we're going to do frame.set resizable to full, so we can't resize the window, and do frame.set location relative to null, means it's going to be centered aligned in the center. We could also do like 200 by 200, type it in manually, which is going to be very, very difficult. We're just going to go with null. So got the null, means it's just gonna go to the center here. Then we can do frame dot set default close operation, jframe dot exit dot close, so you can actually close the window down, which is quite important if you ask me. I want to be able to close my windows down, so I'm gonna have to force close them from our activity handlers, whatever. So what we want to do here is frame.set visible. I said that a lot. What we want to do here, I like how it always comes up proper. I'm like, what we want to do here when I do tutorials. I guess it just gets a little funny sometimes. But we're going to set the visibility to true. So whenever we click the run button up here now, it's going to ask us if we want to run it as a Java applet or Java application, because this game is both. It's a Java applet and a Java application. So it's a little bit unsure how we want to run this, and we want to run this as a Java application as of now. Okay, and it runs like this. Now we haven't set the title yet, but that's probably something we should do. So we can actually close it like that, or just hit the close button up here. Now if we to make sure that the applet part is actually working as well, we want to do run as Java applet. You're gonna see a little applet viewer pops up like this. I actually had that size in the beginning, but this applet viewer is gonna be our game as well, but in applet form, so we can actually put them on the website. So yep, that's that. Next thing we want to do is setting up the game loop. And what a game loop is something that's running all the time, and we can actually get out of it if we like to later. Like if you quit the game, we want to end the game loop. But the game loop is mainly used for tracking when it's like all the movements for the character, all different clicks you do. It's everything. The game, actually not all different clicks, but it's basically everything about movement, timing, and so forth. So all games need a game loop. That's the most important thing for a game. And in order to create a game loop, actually, you can see this line is actually yellow. It's actually yellowish, and that means we're gonna have to do public, or actually private final long serial version UID, and it's going to be equal to 1L, and it's actually going to be private static. And we could have just hovered over this little thing with our mouse, and it would have asked us to create this for us, but I'm just going to type it myself. Or if you change program in the future or something, you want to be able to type this in yourself. It's just for compilation things, so it's nothing too too important. So once that's done, once we got this main file, no, wait, what? So at the end here, what we want to do is we want to type in component dot start. This component method, which is this object, this class, it's created out of this class, which is the same class, but first when the game starts, it just goes here anyway. And then what we do is we create a new component, so it's gonna see, it's one of these objects, one of these class objects, and it goes to the constructor of this class, sets the size, and it then goes back here and we're packing the frame after adding the component to the screen, and then it sees that it had got the size of size, which is 700 by 550, means that the frame is gonna set a nice size, which is that size, and we set the resizability to false and so on, so forth. Actually, just gonna do run as in Java application again, so we actually get this window up. So I actually saw one more thing that we want to do. We want to create a public static, so we can access from other classes. String name equals now Minecraft 2D platformer adventure, or something like that. You don't have to type that. You can type something else, and we're gonna type that in after the packing frame. Not important where you actually type some of these things in. Some things are important, like you set the location relative to after actually setting the size. Else it's just gonna be like, oh, I'm gonna set the position of a frame that's 0 and 0. Oh yeah, it's just gonna be in the center, and then when you actually set the size, it's just gonna go down here. So that's something very important that you do. So that's that. Once that is done, is to yeah, we're gonna set up the game loop. That's that. So have the applet here. When type in implement runnable. There you go. Implements runnable. And this is actually taking. It want us to use all the methods from the runnable class, and add unimplemented methods. We could just click, but I'm just going to type it out alone. So this takes a method, or it wants a method, which is called public void run. So public, it's a run, a method called run, and this run method can be used to make threads and so forth. So as you can see, we're actually starting this here. So what we want to type in is at the bottom here, new thread this dot start. So we're creating a thread out of this class, and then we're starting it directly after that. So, and what a thread is something that you can run multiple out of. You can run more than one thread at the same time, which is very, very handy when you make games. So, yep. So in our public void run method, we want to have our game loop, and because we want the game, this method to be able to run more, to keep running, and also want to have a game loop. For example, if we have some more things that has to be done, we can use the start method after starting the game loop, because it's gonna be fine. It's gonna be accessible. These rows are gonna be accessible after the thread anyway. So what we want to do is in here, want to type in while. We're going to create a while loop, which is going to go on forever while it's running. So while it's running, our boolean that we're going to create in a second is equal to true, and that is something we can create up here. I'm going to find a nice place for it. So public, it's just going to be public boolean. Actually, we can make it static so that it's actually accessible from other classes. Boolean, and we're gonna name this. We're gonna name this to. Is running, and it's gonna be equal to false. Now you might think this is only gonna run while the is running is equal to true, and you set it to false. That's because I want to be able to have full access for this. So in the start method, we're actually setting it to true in the beginning here instead, like that. And above here is where we are gonna define defining objects, etc, etc. So here we're going to define things and then starting game loop. And these things I'm doing right here, these forward slash or just slash slash. This is a comment, so this is not going to be compiled into a game when it's actually compiling into something that the computer understands. So, yep. And in this stop method, when you stop an applet, this stop method is called. So what we want to do is running equals false, and that's it. That's it. So in the is running method here, what we want to do, we could just do a system out print line to check if this is working, and that's what we're gonna do. So whenever we run this, you should get a lot of haze, just like hey hey hey, a lot of spamming there. We'll just spam you forever. But if we just keep it like this, there's a small percentage chance, or actually not a small, a large percentage chance that we're gonna get a lot of lag, since this is just like running. Just it's doing it in a fantastic speed, and it goes up and down a little bit. Sometimes it's like at 1,000 FPS, sometimes it's at 2 FPS. Just get very chaotic. So what we're gonna do is we're gonna, each time that this does its thing, we want it to sleep, and we want it to stop for like 5 milliseconds. So the way we do this is we create an exception handling like this. We could just do that and print the stack trace, but I'm just gonna, or print out the errors, but I'm not gonna do that. So in the try here, you see I created a try and catch block. It's checking for errors, and if it sees an error, it goes here in between these two. That's why I showed you that you can do it in this way, but we're not gonna care about that. We don't want to show any errors as now. So what you type in here is thread dot sleep. Since we're not creating any new thread for this, and we're just creating a new thread directly and we're running it, what we do is we're just calling the whole thread, and we do sleep from the thread. So we're just sleeping with the object. We're just doing a sleep. So it means stop the game for 5 milliseconds, wait 5 milliseconds before you try drawing and doing your thing another time. So here what we're going to do is we're going to type out render and tick. Now an important thing is actually to have a tick before the render. I normally say quiet to myself when I'm doing this. Tick before render. That's something I remember. Tick before render. It's not important, but it's much easier when you create games to remember that it's good. It's always good to do the ticks before rendering. And everything I'm showing you right now is things I've mostly learned myself the last couple of years. So if you feel uncomfortable with me teaching you, then that's fine. But I promise you, everything is gonna be all right. Alright, we got a tick. We're calling it a tick method and a render method. So we have to create these. Public void tick and public void render. So each time that this game loop goes, it's first going to call the tick method here, which is doing all the things like it's moving the monsters, for example, your own movement, your character's movement, whatever you want to do, like you move, you do random stuff. And also we got a render method here, render, public void render, and this render method is basically drawing things on the screen. So what we're going to do now is we're actually going to draw some stuff on the screen just to make sure that we can get this working, because this is something very important that we can draw on the screen. It's like priority number 1. So up here at the bottom, I'm going to do it. We're going to create a public or actually private image. And the private means that it's only going to be accessible inside this method. Private image. We're going to call this screen, and we're just going to stop right there. Now, this is a screen image. This is what is shown on the actual screen. So now we want to jump down to the run method, and before we start the is running, we want to do screen equals create volatile image. And then it takes two parameters, the size of the actual image. And now we want this to be a pixelated game, which means that we're going to do another public dimension, or we don't have to do, we can just type it in manually, but it's going to get a lot more access, and it's going to be a lot easier to edit this if you don't hard code this, which means just typing in the numbers manually. So we want to do public static dimension pixel, which is pixel, so you're going to go with pixel equals new dimension. This is going to be for the pixel size. So before actually typing anything in here, we want to declare what the pixel size is. So what the size for each pixel is. Public static, actually we can make this private since we're only going to need it inside this method. Private int pixel size is equal to 2. We want each pixel in the game to be 2 by 2 pixels. So what we type in here is size.width, which is the width of this thing, which is 700. Then we're going to divide that by the pixel size. We're going to do the same thing with width at height, or size at height, and divide it by pixel size. And it has to be static, since we also can't use it in a static reference, so you're going to have to make it private static. So as you can see, we're creating this, and that means that it's going to be half the size of this. So a recommendation would be to not use 550 here, but 560 instead. Like almost the same. So down here now, we want to create it using the pixel.width and pixel.height. If I just run this real quick, you can actually see that it's not really changing. You can extend this a little bit later if you'd like to. I'm just trying to get nice sizes so we can actually work with this. We're even going to mess around with the sizes a little bit more. So that's that. Now down here under the is running method inside the render method, what we want to do is we want to create a new graphics object, graphics G, and the graphics objects are things that you can use in order to draw out images and rectangles and whatever you like to draw out on the screen. You can draw it out on the screen, and it's amazing. I guess it's amazing. Anyway, alright, so in order to do this, we got the graphics G object, and it's gonna be equal to screen, which is this image here, dot get graphics. And the reason that we're creating it right here is to make sure that the screen image is not created multiple times. Just before we move on now, why did I type in here create volatile image? The volatile image is fully accessible from the graphics card, means less lag. So we're actually making this game on top of our graphics card, which is very good, which many Java programmers are forgetting, which means lag, and lag is not good in my opinion. So what we want to do now, once we've gotten the graphics from this, what we can do is we can type in g.fillRect. Actually, we want to make a little comment here saying drawing things dot, and first of all, we want to set the color. So g.setColor, that means set the color to new color, and this is RGB now. Oh, the sun disappeared. Awesome. And we're gonna use 255, 100, and 100, which I like. It's a red, should be a reddish color. I like these reddish colors, so we're gonna go 255, 100, and 100. And what we want to do now is we want to, since the G object is using this color now, everything that we draw out, except images, are gonna have this color. So if you draw an image out on 0, 0, 100, and 100, now the 100 and 100 is gonna be 100 fake pixels, so it's gonna be 200 for our eyes. But since we're using a little bit bigger pixels now, it's actually gonna be 100 by 100, but in bigger pixels than normal pixels. So that's that. So what we want to do next is we want to do g.dispose. Actually, we want to do that soon, so we don't dispose it before doing anything stupid, or so that we don't do anything stupid. Yep. So we want to do g equals get graphics. I'm gonna take you through all this, what it does, in a second. So g.draw image screen at 0, 0, and I'm probably gonna do this in the wrong way, but I think it's first the real size, yeah. So size that width, size that height. I apologize if this is gonna be the wrong way. Pixel dot, no, actually 0, 0, pixel dot width, pixel dot height, and then null, since we don't have an observer drawing an image. So whenever I draw, I run this now. Yep, it kinda works, I guess. So yeah, it works. So what this is doing is that we are first using the G object to get the screen.get graphics. So this is linked together with the screen object, means that everything we draw here is drawn on top of our screen image. And then we're doing a get graphics from the normal graphics, which is on the applet here, or on the actual surface, drawing surface, and then we're drawing that. So that's what we're doing. So, and then we're disposing the object, means that we're just throwing it away, so that we won't get any lag from having too many graphics objects. So that should work out. If we want to make sure that this actually works, instead of drawing 100 by 100, we can draw by screen dot get width null and screen dot get height. So whatever height and width this image has, and all these null, I'm just typing out this image observers, which I'm not really familiar with, or with. We're not going to use them. They're just something we don't really need as of now. You can see that it's actually drawing it out on the whole screen. Now, since this is an applet, you can see that it's actually leaving a little line here, and we're gonna fix that manually before we're finishing this off today. So that's that. That's amazing. So we just created our base for a game. We're gonna go on for like 1.5 hours more, or so. So what we want to do now is actually first of all rendering the blocks. Since we've got the render method working, drawing on the screen working, and we're just going to start off with the tick method here, which is going to be movement and things, etc., as I said before. So we're actually going to start by drawing some blocks onto the screen. We're first of all going to try to draw some rectangles, and after that we are going to draw some images for it, and yeah, that's that. So that's gonna be quite interesting. So without further ado, no wait. Alright, so what we're gonna do now, as I said before, we're gonna create the box. So create a new class, call this room or level. It's just an easy way to see what kind of thing this is. So I'm gonna type in level, and you don't have to name it room or level. It's just an easy way to see what it's holding. So all classes you create, it should have a good naming. For example, the component we now know holds the actual component, or the working area where we are drawing things onto and stuff. So we got the public class level, and in the level, whenever we create this layer, when define this object, we want the constructor of this. So public level. We also want a public void render, and also a public void tick. For instance, we want to have like falling blocks, like sand blocks and stuff, like falling sand blocks in Minecraft, you know. So, for example, if we want to have that, we got our tick method. Probably going to use a method that we're going to call update in the future, but we're going to have tick here. Yep. So what we want to do now is in the level method, whenever we create this, we want our blocks to be defined. So we also need a block class, and this block class is going to be extending something called the rectangle. And the rectangle is something you can easily draw out on the screen, and it's imported from the java.awt. So the block method here, and you can actually see that this is yellow, like the one that we had in the beginning. So instead of actually typing it out this time, we're just going to hit there, and it's actually going to type out exactly what I wrote before for the first class. So if you're extending something, you want to have a serial version UID. So as you can see, we got the component here, we got the level and the block. So first of all, we're going to create this level so we can actually go ahead and draw it on the screen. So how we do this is at the bottom here, to make it look nice, we're going to type in public static so it can be accessible from other classes. Level, we're going to call it level, and that's actually it. And here, as I said before, we're going to define our objects here in the start method. As quick as it goes in start, we're going to define all objects before starting the thread in the game. Going to type in level level equals new level. We can mess around with these if we want to have like loading bars and things later on, but for now we're just going to define them here. So now this level is defined. That means that this thing is gonna be called, and it's gonna go through this method here before it's gonna move on and go here. So, alright, we also want to draw this on the screen so we can just run into the level and work on that in a little while. We're going to remove the set color and the fill rect. So what we're going to do is we're going to type in level. Actually, we can keep the g.set color so we don't have to set that to something else later on. But we want to do set level render, and also type in the g here, and we want this to take in a graphics G object, and this is of course imported from the java.awt where we got all our graphics and stuff. So as you can see, now it's not going to be an error anymore, because this method now want to have a graphics G object, a graphics object that we're going to call G inside this method, and we are taking this G object here, so it's actually drawing it on top of the screen image. Alright, so in the render method here, we want to draw out our blocks. We haven't even created blocks yet. So at the top here, we want to create a multi-dimensional array. Haven't even talked about arrays yet in my my beginner's tutorial series. Probably when you're watching this, I probably already have, but anyway, you might be from the future for me. I might be from the Stone Age for you. That makes sense. I type in public block, and actually here, to make it look great, we could have put these two after the block. This is indicating that this line is a multi-dimensional array. That's at least what I call them, and it's gonna be equal to new block, like that. Now we want to know the sizes of our array, and this is gonna hold all of our blocks. So what I want to type in here is we want to type in probably something like let's see, let's just say that our world size is going to be 50 by 50 blocks in the beginning. Then as quick as it gets in here, it's already going to have this defined already. Actually, it's just defining it as quick as it gets in. Then it's going to be 4 int x equals 0, this is a for loop, block dot length x plus plus. So we'll go through the length of this array, so 50 times. And these are just this number here. We also want to go through this number, since this is 50 times 50 with blocks. So when we go for int y equals 0, this is for the y, and the y is going to be these two here. Block 0 dot length and y plus plus. So now once we've gone through both of them, we're basically creating a loop, and then we're creating another loop inside that loop. So first it takes one row, the first x row goes like that. Actually gonna open up my glorious little paint here. So basically just to show you guys how it actually works out. It first takes block after block. So block, 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 block. Takes 50 times. This is the first for loop, goes there, and it's basically the first for loop indicates that what row it is on. Actually, it's going this way. No, wait, it is going. Yeah, it's going this way. Alright, so it takes block after block. So y0, first it's on the x0 value, so it starts here, which is the x0, and then inside that x, when it's doing the y coordinates, it takes y1, y2, which is also on the x0 in the x0 column. So you should have worked with grids and stuff in school at least, so you should know about this. And then after going through this for loop, so 50 times of y coordinates, it will increment the x by 1, since we're typing that out here. X plus plus means increment x by 1 or increase x by 1. Same with the y here, it goes 50 times, then it stops, goes out of that for loop, takes the x, the next x1, so it's going to go like x1, and it's going to do the same thing over and over again. So that's that. So now once we've got that finished, what we can do is we can create our block x, y, and equals a new block, since this is the method block. But we're not able to set the size of the block. So the way we can do this is we can create a constructor inside the block method here. So public void block. So let's say, alright, not public void block, public block. Let's say that this is going to take a rectangle. This is also a rectangle, but a rectangle called size, so that it has something to set its size of. And as you can see now, it's going to give us an error because we're not giving it a rectangle, so its size. We also want to have inside here, we want to have a public int. Public int. We might want to be able to access it from the outside, and it's going to be called ID, and it's going to be equal to. It's going to be a multi-dimensional array, so we can easily access any blocks on our tile set later on, where we're doing some image stuff. But we got the ID. We have the ID to indicate if it's a grass block, a dirt block, or actually I would like to call them earth blocks, since dirt is that's so dirty. I don't really like dirt. It feels like mud, and mud is making me unhappy. Oh, it's raining outside. Wonderful. I like rainy days for some weird reason. There's a strange bug on my window. Interesting. I'll check that out. Actually, let's do that later. So this is going to hold two different positions, so I'm going to do that right now. And you can also define arrays by typing two of these spike bracket signs, whatever you want to call them. And -1, -1 is going to be my air blocks. And in order to give myself some tiles, I'm going to create a new class which is going to hold tile values and so on. But I'm going to call this value. Actually, let's have everything in a method called tile. All values and different things to make it so that actually makes sense. The tile class is now also going to hold like different things from the character, like the character animation if you want to animate him, which you guys probably want me to, so let me show you guys how to animate. I guess you do. So this is also going to have a constructor, because when we want to import images, we want this to have a constructor, so we actually have something to call in order to import images. Now up here at the top, we have all of our different variables. Of these are going to be static, so we can access it from the outside of this class. So public static air is going to be equal air. Our air object is going to be equal to -1, -1. So tile x is -1, tile y is -1, and it's going to be an int, and it's going to be an array. We'll also want to create the first block here, public static int. I'll type in dirt, or actually earth, to make it a little bit more sense. And this is going to have the value of 0, 0. Now the 0th coordinate in our little tile set with different images is going to be at the top up here, of course. So it will basically, our tile set in a second is going to look like this. We're going to have different grid spaces like this, and now when we're creating these array things, -1, -1 would be outside this, so we're just going to check that so that it doesn't get any errors. And then also 0, 0 is going to be x0, which is here, y0, which is here, means that it's going to take this object. But imagine that we had instead of that 1, 0 here, means it's going to be x1, but at the same time, yeah, and at the same time y is going to be 0, so it's going to be right here. But if it was 1, 1, it would go here instead. So that's basically how that's going to work. And I thought that it might be good if we did it this way. I just got the idea, but it's going to work. I know that. I know what I'm doing. I've said that before. So in the level method now, we're just going to show an error. So we got the ID, which is -1, -1. We also want to give it outside here when we're creating these block method objects. We also want to give it an integer, which is an array. Call it ID. So whenever it gets in here, we want to set the bounds of the rectangle. Means it's going to set the x, y, and width and height coordinates of this, and it's going to be set to size here. Also, we want to do this.id is equal to ID. Now we need to have this.id here, and you might ask, why do we need to put this here? It's because it's gonna, if we would just type in ID, that's just gonna be very, very stupid. That means we're gonna set this ID that's in here, because it's always checking for this first if we have any objects called ID in here. So it's gonna check for this ID. So ID, this ID, and we're gonna set this to the same object again. It's very stupid. So we're gonna have this.id means this ID here is gonna be equal to this ID, which is here. That, I think that makes sense for you, or most of you at least. So now, as you can see, we got a rectangle called size and an ID, or an integer called ID. And in order to do this, we're going to create a new rectangle inside this, and this rectangle is going to be, oh yeah, we need to set the block size. So a good block size, I have no idea what it is. Public static int, it's going to be in the tile method again, by the way, so we can easily access it. We're going to set it to equal to set it equal to I want to do 16 because we get very nice sizes if we make it 16. Could as well make it 20. Int block size equals 20. I should probably call it tile size to make it a little bit more sense, both tiles and blocks. And in this new rectangle, then we want to type in x. First, the rectangle takes an x coordinate, and it's x. This is the x. X times tile dot tile size. It's going to be the x position times tile size, since each one of these is going to have the tile size as width and height. So, and we don't want to create them on like position 1, 1, 2, 2. It's just going to be small pixels. It's just going to look horrible. So it's not really going to be a game, and we of course want to create a game, so we want this to work out. We want this to work out. Oh yeah. How you want this to work out? Huh? Yeah. Interrupting brain. Interrupting brain says what? Interesting. But now to the width and the height. So we did the same with the Y, and we're gonna do the same with the width and the height. Now we got a rectangle here. After creating the new rectangle, which goes here, after that we want to give it an ID, which is going to be tile dot any ID. We're going to give all the tiles earth for now. We're also going to create a public void generate level method, so we can actually give it a random world generation. Now I'm not going to make it take too much time creating the level. So we got the tile earth here. Tile earth. Tile earth. And actually going to change this to air, so everything is going to be air objects while we are rendering these blocks. So in the generate level here, we just want to copy this here into here, but instead of typing this, you only want to mess around with the IDs for the blocks. So if we want to render a quick little room for this, if x is equal to 0, or y is equal to 0, or x is equal to block dot length minus 1, or y is equal to block 0 dot length minus 1, then what it's going to do is it's going to set the block x y dot id to tile dot earth. Now we're just going to render a quick room for now, and what this does is if the x coordinate, so if the x is up in the left top corner on the screen, we want to give it earth blocks, and or the first row column. If y is equal to 0, which is if y is equal to 0, which is the top here. If x is equal to 0, which is the left side here. If x is equal to block the length minus 1, means it's going to be here. Since it's starting on 0, hence the block values are starting on 0 here. It's also going to be minus 1 when it gets to the bottom and the right side, so on. So, yep, I'm just looking outside on the rain. The rain annoys me kind of when I'm recording these tutorials, but not a big deal. That means that we're rendering a quick room, and we're also going to mess around with the generation code later, so we get a nice world, a pretty nice world with some mountains and some girls and girls. Yeah, exactly. That's what I'm thinking too. So once that is done and rendered and all that good stuff, what we want to do, oh yeah, what we want to do, oh yeah, what we want to do. Yep, what we want to do after rendering the level is drawing the blocks out. So I'm going to create a public void render method in here, and it's of course going to take a graphics G object as usually, and we're just going to draw these directly. So we're going to copy this for loop again, so we get all the blocks. But instead of typing this again, you're going to do dot render, so draw the blocks out on the screen. And just going to say that so it sees that it's actually taking a graphics G object. So that makes perfect sense, I guess. So now all of the blocks are going to be drawn out on the screen soon, after we've actually created this. Now, since the color already is set to red, we don't have to worry about any changes for color. So in the render method here, what we want to do is we want to type in G dot fill rect x, y, width, and height. It will just run this straight away. It's gonna give us this, so it's just gonna ignore If any of these blocks here on the screen, which we can't really see right now, is something, if is anything else, or is air or anything else, it's just going to give them red colors. But to make sure that it's not checking for the ID, since we're going to get trouble with the images if it's -1, -1, you want to do if ID is not equal to, so exclamation mark equal sign, tile.air. As long as the ID is not equal to tile.air. As long as the ID is not equal to air. Which didn't really, oh yeah. One more thing is that we have to call after this in the level constructor here for the level method. Generate level. We got a call here. So we're actually generating the level. So whenever I run this now, we're getting this. As you can see, we can't really see all the blocks on the screen. We can only see some of them. So what we want to do is we basically just wanna we want to add some side scrolling in the future and stuff, or not in the future, in a few seconds. But first we're gonna give them images, and also we want to get a background color of this. So we're just gonna ignore that the images or the blocks is actually drawn, and we're also gonna have to change the rendering code for each block. But we want to do g.fill rect, so the blocks are not gonna be seen now. 0 pixel width pixel height. That was terribly wrong spelled. So now we're gonna draw out, so it's gonna be black. Actually, let's set it like kind or something like that. Red, green, blue, 100, red, green, and blue, 255 or something like that. Yeah, that's quite a nice sky color. I'm gonna use this as a sky color. You can use whatever you'd like to use. I'm gonna use this. So what we want to do next is we want to go into Photoshop or any painting program. If you don't use Photoshop, you're not gonna get my instructions for this in your way. You can just use paint.net. It should be fairly simple for you to do, or just normal paint. Any painting program. In any painting program, you want to do File, New, and since each one of our blocks is 20 by 20 pixels, we also want to draw them in 20 by 20 pixels, because the pixel size is already fixed in the game, in the rendering, for the game image. So we can just draw all the pixels in the correct size, which makes it a lot easier for us to calculate what sizes we use. So for the width, we want to go with 200, and here we want to go with 200. That's going to be 10 by 10 images. Well, that's generally 100. I'm going to go with more of them. So 400 by 400. The 20 by 20 things here. I'm going to zoom in, hold my Alt key, and scroll with my mouse wheel. Now we're going to find 20 pixels. How large 20 pixels are? That's 8, that's 16. 1, 2, 3, 4. That's 20 by 20 pixels here. And we want to give this, we want to mark these off so we can actually see where we are drawing them onto our things. We make them like that. So I want to do Control C on this. You can of course just draw them in 20 by 20 scales. Now I'm gonna fill this with this whole image, a lot of these. I'm just gonna put some of them out, and then I'm just gonna start copying. So I'm gonna merge these layers. Gonna Control C. I'm gonna start doing this a faster way, and I think I missed some there. Yep, I did. That's awesome. Gonna do this again. So as you can see now, we're soon going to be able to see where to draw our images, and this is making it a lot easier for us to develop these, or this. So we got that. got that, and then the last piece here gonna fall in place. There we go. So now we can start drawing these things. So the first block, as you saw in our tile here, it's Earth, and it's on 0, 0 on the coordinates. So it means this block right here. So I want to mark this off with my marquee tool. If you're in any other painting program, it might be hard to mark it off, but I'm gonna do that so I can only draw, so I can't draw outside this. Now since this is gonna be dirt or earth, I'm gonna find a brownish color for this. This should be under the orange scale. Oh God, why? There we go. So we basically actually gonna use the fill tool, and we now got some fairly simple earth. And I'm gonna be too lazy to actually make something very nice. I'm just gonna leave that to you guys to make something very nice. First, I just wanna spam this with some different random color scheme. Something like this looks fairly nice. Like something like that. Now we want to hit Control S in order to save, or do File up here and then Save. Now we want to go out. I've saved mine in Dropbox. YouTube tutorials. YouTube Minecraft platformer. That's what my Eclipse workspace space's name is. Client. And then here I want to create a new folder. I want to name it res. This is for all my resources. Now in here, what I want to type in is I want to type in. First of all, I want it to be a PNG file. Then I'm gonna call this tileset underscore terrain. So this is a tile set now. I'm gonna save it. Hit OK. And we now want to go back to our Eclipse. So now what we want to do is we want to import this image. So in the tile class here, I want to do public static buffered image, which is a buffered image. Is very good for if you want to draw games without any strange flickering kind of looks. So we're gonna call it buffered. We're gonna make a buffered image. And now after the buffer image, we'll also name it as usual. So tileset underscore terrain. So now, as you can see, we are getting an error because we haven't imported it. And you're going to see that it's under the java awt.image. So we want to import that. Import java awt.image. Alright. And in order to load the image up using the tileset terrain, first of all, we want to right click at the client and refresh this, since we got a new folder in here that we created. And you should find the tileset terrain in there, so you can see that there. So what we want to create is for the tile. First of all, we have to type in try and catch. We have to create a try and catch block, as we did before with a thread. You should remember what it does as well. I told you that before. And we want to type in tileset terrain, which is our buffered image here, equals image io dot read. And this is going to be reading a file, and it's going to be a new file in here, which we want us to, as you can see, file java io, and this is the image io. So import java dot io. So you can go ahead and use the file, because this takes a file on the computer somewhere. So in here we want to type in res, which is heading to the res folder directly here. Res forward slash tileset underscore terrain dot png. the file extension is PNG, so tiles of terrain PNG. Ooh, it stopped raining. Cool. Right, so now this is not loading up, and we also need to type tile.tiles of terrain so it gets its static reference, and via the static method it loads it up here. That it is not only inside this little tile here. So in the component here, what we want to do is that we want to yawn. So right here, first of all, we want to type in new tile, and that means it's just gonna go over here. Going to type in loading images. We're normally putting comments on loading things up and some graphics, things like drawing, so I can easily find them in the code. But this is for loading the images. Loading images is going to be inside this try and catch block. If we would remove this, we would actually get an error. This needs to have a try and catch block when you're loading them with the image.io.read, since it normally not normally it crashes sometimes, or not really. It doesn't crash if you do it in the right way, but else it's just gonna lag up, and you're gonna get a lot of problems if you load it up in the wrong way without using a try and catch. So it says that you must have a try and catch block for this. So since we loaded up from the tile, we can actually go ahead and use it now. So in the block method here, instead of drawing a stupid fill rectangle, which is blue right now, which is quite interesting, we want to do g.drawImage. Before these coordinates here, when I have various different things, when I have tiles of terrain, when I have these coordinates here, when I have id 0 times tile.tile size, id 1 times tile.tile size, and then since these are using the coordinates left, top, bottom, right instead, we need to type these and do, instead of just the old wait, what did it just do? Interesting. But we basically want to take these again like that, and we want to take is plus tile.tile size and plus tile.tile size like that, and then after that the image observer, which is null. So these are basically taking the coordinates instead, the exact coordinates instead of the width and height. So we're gonna have to modify that code a little bit. So when we run this now, there's probably something wrong with my dirt blocks. Wait, let's move these coordinates here over to here. Nope. Oh yeah, but because we're gonna have to do x plus width here and y plus width here. Here we go. And this is gonna give us a nice dirt blocks all the way around here. So we've actually loaded up the images successfully, and we've got it working. So that means that while we've actually gotten this work, we can actually start by first of all adding first of all, we don't want to render all the blocks at the same time over and over again. Only the blocks that you can actually see on the screen. I want to go over to the level here, and but first of all, we need some more things here. And in here, we want to have a public static int called sx and sy. These are the side-scrolling coordinates, so we can actually scroll and walk around in this little world. So sx is going to be equal to 0. Going to start as the 0, 0, and now then, first of all, here, what we want to do is we want to draw all these minus component.sx and minus component.sy. This might take a little while. There is another way you can do this. You can just translate it, but that means a little bit more lag, because translations in Java is not really. At least I've learned that it's not the best thing to do. But this works as well, so that's very good. So before we do anything else now, we want to create the character before we actually optimize this. And instead of using the old nice rectangle, we want to be able to set exact speeds. We want to have like it moves 0.5 pixels each turn, or whatever. We want this to use instead of using the old rectangle. What we're gonna do is that we are going to do what are we gonna do? We're gonna do is gonna create a new class. We're gonna call this double rectangle. Now this is gonna be just like the old rectangle, but it's gonna use doubles instead. Instead of using integers at the coordinates, we're gonna use doubles. So you want to type in double x, y, width, and height. Public double rectangle. Or here we're gonna have two different constructors. One that we're gonna be able to do without taking any parameters, and the other one is gonna have int x, int y, int width, and int height. Actually, doubles all of them. Double. Just take this and copy. So in here, what we're gonna do is we also want to have a public void set bounds method, as just like as in the normal rectangle. You can set the bounds easily, and this will also take these objects here. So we want to set the bound whenever you create it with if you create it with this way, we want to set the bounds to 0, 0, 0, and 0. But if we create this with this way, set bounds x, y, width, and height, it's going to take, and then you will set this.x equal to x, this.y equal to y. You should know why I'm putting this now. If you don't remember, just go back in the video and watch. Equals height. We'll now set the sizes of this. So in the character class now, we would just want to extend this with double rectangle. So in here, what we're going to do is going to do public character, and we also want to have a public void tick method and a public void render method. Now we want the character to have 2 block size. So in this sprite sheet here, I want to scroll down to the bottom of it, and I want to create the character right here. The first thing we're going to do is just draw a character. So as I said before, we want to have it to be 2 blocks high. And I'm not going to do any big animations. I'm going to have some basic animations, how to do some basic animations for this. But this is going to be our basic character. She should actually not be pink, but let's make him like blue or something. It's blue, oh yeah. Okay, cool. So we got our character down there. As I said, I don't really want to go into making him really advanced, so I'm just gonna keep him as something like this. So I'll do the same as I did with the dirt blocks or earth blocks, whatever you want to call them, just to give it a nice little random feeling when you actually play around with him. This doesn't look as good as the dirt blocks or earth blocks, but it's definitely working. And somewhere around here, we want to put the eyes. There you go. So we want to save this again as a PNG. Just want to double click this to save it over. And now we've got the character. So now we can create, if we go, that's Skype. If we go over to this, we go to the double rectangle. It's character, render, oh, wait a second. Yep, so in the tile, which we can't see right now, if you want to have this larger, you can just double click this. It means that this Package Explorer is going to be under this little button here. The console is going to be here, and so on. So this is where we printed out some stuff out before. But in the tile here, we now want to set out the position for the character. So public static int character is going to be equal to, you can actually count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now I could just have taken, this is the 19th slot minus 1, but I just wanted to show you what you can do. So 0, 18, and then we want to go over to the character. Alright, so first of all, when we're creating the character, we want to define how large he is actually going to be. He's going to be int x, going to take an int y, int width, and int height. Now all these are going to be doubles, but so we want to do this dot x. We actually want to do set bounds x, y, width, and height. And when I do this, that's going to work perfectly fine because it's easy converting integers into doubles. So now we've actually set the size of this object, but we need to create the character before we can actually display him on the screen. But the size, or the x and y, you're gonna see how I place him later on. We could actually just do to make it easy for me whenever I gonna type his position out, just give him width and height, and the x and y is gonna be instead the component dot pixel dot width divided by 2 in brackets minus width divided by 2, like that. The height and the height. Now we've got him in the center. Now he's centered line. So now what we can do from the component method here, we can create a character as well as a level here. We've got the level. So public static character, so we can access it for other classes as well, character. And with the character here, what we're going to do is that we are going to define him. So here, character cancel equals new character. I don't know what happened there, but now we want to have the width and the height of this, and it's going to be tile size for the width and tile size times 2 for the height. So we got that already set up. To make sure that the character works as quick as we render him above the level here, render, we're probably going to move him back one level in a second. This is of course going to take a graphics G object like usual. Oh yeah, actually graphics G means we have to import java.awt. And in the render method, what we want to do is g.failRect and it's going to be x, y, width, and height. Now this is going to give me an error, so we have to cast these into integers before we can actually use them. So that should do that. Dot set color is gonna be new color. We're actually gonna set this to red for now. Then we're gonna import the image and use on top of the character. As you can see, we're actually drawing him out on the center of the screen, in the center of this little screen here. So we've soon got the character working, and he's soon set up. So what we want to do with the character now is that we just want to draw an image for him. So g.draw image, and when type in the image, which is on tile.tileset terrain, and then to the tile.character, which is going to come soon. So we're going to have cast these int x, int y, int width, one last thing, int height. Now what we have left is the actual position on the tile set, which is on tile.character 0 times tile.tile size, tile.character 1 times tile.tile size, tile.character 0 times tile.tile size plus width casted into an integer, and tile.character 1 times tile.tile size plus int height, and then of course end it with null. Now we should be drawing out the image on the screen. Oh, that didn't really work out quite as going to plans, I guess. So if I could just go through all of these. Yep, again, I did the same mistake again. So it's gonna be y plus height there. Of course, we're gonna have to cast these. Actually, what we can do instead of having to recast them, you could just put brackets around these two, means that both of them are going to be casted. So whenever we run this now, we have got the character in the middle here. Looks a little bit too tall. You can of course mess around with the size for him. Shouldn't be too much of a problem for you. You guys should be pro. You guys should understand how to do that if you've been following along the whole tutorial. So that means that works. Now, if we want to see the character fall, what we're going to have to do is in the tick method, we're going to have to put, first of all, in here we want to set how much the character falls, or what the falling speed is. So public double falling speed equals it's going to be equal to 0.5 or something. So each tick y is going to be plus equals falling speed. Now we're not calling the tick method, which I forgot about. So we want all the tick methods to be called here. So level.tick, character.tick, and then we want it to continue on. Alright, so you can see he's actually falling. We want him to fall faster and so on. We are going to have to increase this. So 1, for example, it's going to go quite fast. 2 is going to go even faster. Now, it's not that smooth for you to watch me, but since I'm recording at the same time with Camtasia Studio, but try to find a nice falling speed. It should be the same speed when I go out of recording. So 1.3 should be good. 1.2 You can mess around with that yourself. 1.3 I'm gonna go for. I want it to go quite fast downwards, and at the same time I want the component dot sy to be plus equals falling speed. And if you see now, it's just gonna this thing is gonna be falling, as you can see, but the character disappears from the screen. That's because we haven't been doing component dot minus sx and so on, so forth. This is only gonna change this on the position here. So minus sx and minus sy again. There we go. Yeah, exactly. This goes since this is an integer, it's just going to go down to the point number goes there. So what we have to do is we have to change these two into doubles, and we have to cast these things into integers so we don't get any errors. Casting is one of the most important things when you're working with doubles and integers, objects that should take integers. When you put in things like doubles in a place where there should only be integers, you have to cast them to not get any errors. Well, a lot of casting is done here. We can run the component, and as you can see, it's actually shaking a little bit, but it's fine. Just a little bit of shaking in the beginning, and then it's working just fine. So that's that. So what we have to do next is we will have to yep, can't say I won't, but we will actually have to add a collision detection, because as you can see right now, just doing some his things, and it's just falling through the floor. We don't want him to fall through the floor. So in here we want to add a underneath the tick or above the tick, underneath. Want to add a public void collides is colliding with block, and this is going to be a boolean, so public boolean, so we're going to return a true or a false. Now, alright, so this is only to know if we are colliding or not colliding, because this is going to return a true or a false, and if it returns true, we know that it's colliding. If it returns false, then we know that it's not colliding. So that's what we want to get. And in order to get this this thing, we need to do a for loop. For int x equals 0, x is less than. But now a better way to do this, since we are actually it's better for us to calculate where on the screen the character is. So what I want to do, instead of x, now x is equal to let's see, is equal to x divided int is equal to int x, so cast over to an integer, divided by tile size. Yeah, it is equal to that, yeah. And it's gonna be less than this plus 3 and x plus plus. Now we are of course going to have to do this dot x instead, and then x is less than this dot x plus 3 There we go. So we are gonna do the same thing with the y, but instead of having x here, we're gonna have y. Now this is taking the exact location for where our x and y actually is, so we're not checking too many things at once. But inside this boolean, we're gonna have another boolean, and this boolean is gonna be equal to, or we're gonna call this is colliding, and I want to set this to false as of now, because we don't know if it's colliding yet. So if yeah, so in here we want to take two different points pt1 and point pt2, so we know what thing to check. And points are basically like, it's just points on the screen, it's coordinates. So we want to know where this collision is happening, and we want to give it basically if is not colliding. That's why I'm putting this exclamation mark before. So while this is giving us a false, point or new point int x int y plus int height, like that. And then another point which is going to give us, it's better if we just cast these, and or we actually just put brackets around the whole thing. I'm going to have to check these multiple times, so I'll do the same thing over here. And it's okay to be confused. It's okay. Just do that. So as you can see, change is colliding. Oh yeah, it's colliding with block. Else this is gonna be very strange. So if it's not colliding with any blocks, it will just keep falling forever. That's basically what it's saying. And for jumping later, we're gonna deactivate that. The first tutorials is gonna be about, or the first tutorial will probably gonna make it to jumping, so we can actually start jumping with our character, fall and jump and move. So if component dot level dot block x y dot contains pt1, or if it contains pt2, I don't think we can type in intersects here. Nope, good. I just want to check something out. So if this is containing this, then is colliding is going to be set to true, and we're going to break the loop. Break out of this loop. So is colliding equals true. And then break the loop. So then outside here, if is colliding, actually what we want to do is then if this happens, we just want to return a true. Actually no, is, yeah, return true, because then we know it is colliding, and then we can remove this, and we can do down here return false in case of it being false, and we can just remove that. There we go. When I do this, run this now, oh yeah, it's not actually not falling. Give me a second. Oh yeah, so we want to check so that this component dot level dot block that we're checking it for, x y dot id is not equal to value dot air, but the id, oh wait, not value, tile at air. I'm used to call it value. used to have two classes that's holding the values, but just to make it easy for you guys, I only had one. So when I run it now, it will fall and fall and fall until it hits the ground, hits the ground. Then we'll stop falling, as you can see. So that's simple collision. We can also use this for moving around, moving to the left and right, and so on. So now what we want to do is we want to add some moving to the left and the right. And then we need to add some keys, of course. So we're going to create a class called listening, and this is going to hold all of our keys and stuff. So all of our, if we hit like D, we want them to move to the right. If we hit A, we want them to move to the left. So before we do anything in there, we want to have different booleans to check. Well, actually not booleans. We want to have an integer, public static int, and we want to call this dir, and it's going to be equal to 0 as of now. And we're also going to have a boolean, so public static boolean is moving, and it's going to be equal to false. So in listening here, we want to implement this my spelling is horrible today with something called the key listener. Now the key listener is checking for different keys. This should be in the Java awt.event. I'm just gonna change that to star so we can easily use other things from there. Add hit unimplemented methods just to make it simple for us, and I can just organize these things so that they look great. So that's that. I also want to rename these to E. That stands for event. Now, alright, we got 3 different methods. Now we haven't really even added the key listening to the component. So after setting the size, want to do add key listener. I want to type in new listening. So we're adding a key listener, a new listening class of something that's gonna be listening for different actions, what we're actually doing in our thing here. So first of all, we want an integer, and this integer is going to be called key, and it's going to be equal e.getKeyCode. So this way we can check what key is pressed down. We want to do the same thing with the released key. Not gonna care about the key typed. We're not gonna use that at all. But if we press down a key, what we want to do is we want to switch the key and see what key this is. So in case of and switches are basically something that checks that can check different numbers instead of having if, else if, else if, else if, and then else. It goes a lot faster than doing that. So if key event dot vk underscore d, in that case we want to do something in there. But in case of key event dot vk underscore a break, what we want to do in here is that we're just going to copy this so that we can see what keys are released. But if we press down our vkd key, what's going to happen is that the component dot first of all is moving is going to be equal to true if it's equal to false, and then component dot dir for the direction is going to be equal to, as d is to the right, which means we want a plus value for where to move. We want to do component dot character dot now movement speed or moving speed is what it's going to be equal to. So we want to create that variable in here. Public double movement speed is going to be equal to 1. I call it moving speed, movement speed then. So movement speed, it's going to be equal to that. And we'll see what we did in here. Oh yeah, and we're going to change the dir from in here to a double, so we actually know everything by using this double. There we go. And I just want to have everything organized in here. So now we're actually setting it to move to the right. But what if the key was A? Well, then we want to set the is moving to true, and at the same time as that, we want to have the movement speed to be minus, or the direction to be minus movement speed. That should work out. So, in case of any of these are released, if, first of all we want to check, if component.dir is equal to its own thing here, what's going to happen is that the component dot is moving is equal to false. But in other cases, if this is not equal to its own direction, then we can't stop it, because that means that this direction, for example, here is if the component is equal to plus, means it's moving to the right, and we're releasing the left key. We don't want him to stop just because we released another key. So we want to make sure that we release the right key and the right place of time and stuff like that and such. So now in the tick here, we also want to check if component dot is moving is equal to true. Well, what do we want to do then? Well, then what we want to do is that we want to increase our x by component dot dir. So whenever I run this now, we can actually move around. As you can see, we can move around on the screen, which is quite awesome if you ask me. We want to change this to 0.5, I believe. But there is also another problem. We want the side scrolling to be working. So x, we want to do plus equals movement speed, like that. Nope, definitely not. Movements. Oh, component.dir. There we go. Alright, that should work out. As you can see, we can now actually move. Now, you can see here that we're not colliding with that wall, so we will have to fix that. A lot of strange moving stuff there. A lot of shaking. Alright, I think it's because we're connected to the level when this is minus, and then it gets a little chaotic. So as quick as it gets to plus, we're not shaking anymore, which is good. So we don't really have to worry about that, because it's just he's gonna get dropped in the middle of the world, and we can even remove this, so we can't even walk over to this. So the shaking is not going to be any problem. Right, so now you can see that we are getting errors, and we are getting an index out of bounds exception. So here we need to check if x is greater than or equal to 0 and y is greater than or equal to 0 and x is less than component dot level dot block dot length. And the same thing with the y variable. So if we change this to y and the level dot block phase 0 here, what we're getting is even if we walk outside of this, nothing is happening. Now we are actually standing inside the blocks, but now we can just keep falling just because it's fun. It's just a small area there where we're actually shaking. It's fine, it's fine. So now we check that, and we fixed that little bug. So now we want to check if we can actually move. So we want to do a boolean can move, and it's going to be equal to false as of now, but we also want to do a switch of component.dir so we know what direction it's moving in, and in case of movement speed, that he's moving in the movement speed. Now this is this is probably gonna give me an error. Component.dir. Oh yeah, this is not gonna work. So we're gonna have to do this instead. So if component.dir is equal to movement speed, and else if component.dir is equal to minus movement speed, like that, what's gonna happen? Ooh, that insect or bug is still on my window. Awesome. But what's gonna happen is that we want to check this in two different ways. So then we're gonna have to set the can move is equal to is colliding with block. So if can move is equal to false, then we can do this, then we can actually move the character around, else it's just gonna stop. So we're gonna have two new points, new point, and there's in this new point, and then a new point here, of course. But in the first new point, what we want to do is we want to type in, since this is moving to the right, actually let's take the left first because it's easier to do, or to deal with. So if the new point is actually equal to int x, int y, int x, int y plus height. What we are gonna do, what's gonna happen is that he will stop. As you can see, now he stops falling as well, and he is actually into the ground, which is quite interesting, but it kind of works. So also want to have really want to have the height just like that. We want to have height -2 or something like that, just to make sure he doesn't get stuck in the ground. Quite boring when he gets stuck into the ground. So we can actually move that way as well. As you can see, he's actually moving, I believe, 1 pixel into that side. So in order to fix that, we're gonna have to do the x here +1, and this should fix our movement problem. No, it doesn't. Well, if that's +1, it should be -1. -1. We can't get this working, we're just gonna leave it to a later date. Yeah, we are at least it's at least kind of working. That's the important thing as of now. So what we're doing here instead is to have int x plus width, int y, of course, and then here int try casting it, but didn't want to. X plus width, comma, int y plus height minus Did you really remove wrong from me again? Yes, it did. Amazing. Eclipse is really being not very nice to me right now. But he gets stuck in that wall. That's amazing. He gets stuck in a wall. And this side, he stops. That's that being sorted out. You're now kind of colliding with the walls. In the next tutorial, we're gonna get everything working with the walls. We're gonna get like these things fully working. But there's also one more thing we want to do, and that's actually gonna be a public int jumping height. It's gonna be about 50, and then we're gonna have a public double jumping speed, and it's gonna be equal to 1.3, just like the falling speed. I'm gonna have it set the falling speed for now. Might want to change that later. Actually, you can just type that by hand. But alright, in order to check if jumping is hold, so we want to have a boolean here. Public static boolean is jumping equals false, as of now, of course. So if he is jumping, but we also want to check if he is actually jumping. So case key event dot vk underscore w, which is going to be the jumping key for me. Break. You can of course put it on any other key, like space. I'm just going to put mine on W, and component dot is jumping equals true. And if this happens in the release keys, it's of course going to be set to false. So what we want to do here is to in our character now, first of all, if he's not falling, so in here, else as long as he's not falling, and if component dot is jumping is equal to true, what we can do is we can have a boolean in here, public boolean is jumping equals false, but we can set it to true. So component dot, no wait, not component, just is jumping is equal to true. And if is jumping and is colliding with blocks, alright, so as long as he's not jumping, this is not jumping, well, because if you're in the air you don't want to have any falling problems. So what we can do now is we can actually code the jumping. So I want to see here, we also want to have a jumping height and a jumping count, which is going to be equal to 0, and also it's going to do the same thing 50 times. It's going to be 1.3 pixels 50 times, so I want to do probably 20, makes more sense. But what we want to do, actually let's put it to 1 just to get a nice nice number. Same with this, Though we don't have like any problems. He should. No, he's not gonna stop doing that. But oh, if we would put this to 1, would he actually? He actually stops doing that if we put it to 1. But I kind of don't want to use 1 because 1 is actually rather fast. So we're gonna keep it at 0.5 as of now. We can do some optimization things later, or some other testings later on. But the jumping height, which is equal to 20, so at the end, if it's moving, want to check if it's moving first, and then if is jumping, if it is actually jumping. So if jumping count less than or equal to jumping speed, jumping speed, no, jumping height, else jumping count is going to be increased by 1, or incremented by 1, and here it's going to go down to 0. Jumping count equals 0. And here what happens is y is going to be minus equals jumping speed, and component dot sy minus equals jumping speed as well. Whenever we run this now, and you see you can't click it there, and we actually start flying upwards, which is quite badass. That's amazing. But we also want to add a check for if it collides with the roof. So first of all, if is colliding with block is equal to false, new point, that's going to be a rather simple one, int x int y, there, new point int x and int y, this one is going to be plus the width. As long as that happens, that's not happening, then it's fine to do that. But else we're gonna break the whole jumping thing. So is jumping false, jumping count gonna be equal to 0. So whenever you see this now, we can't jump while falling, which is good. Now we fly. I am flying. Whoa. Alright, so that worked. So what we can do now is to code the last part of this, and then the jumping and everything is working. And it took me just 2 hours to finish this off and try to explain different things, what I'm doing, and so forth. And so what we want to do in the last thing, when this is reaching this, is jumping equals full. So when the jumping count have reached the jumping height, then it will stop. I still can't jump. Amazing. We can jump. That's not a lot. But if it's less, oh, actually, if it's greater than or equal to, that makes more sense. If I just fall down, I jump. Ooh, nothing happens now. I do small baby jumps. Less than or equal to. If it is less than or equal to jumping height. Oh wait, if it's greater than or equal, yeah, then these, of course. Let me move down here. There we go. Alright, so now last test here. This should work out. Look at that. We can even hold it if we like to. But that's little. That's a very small jump. Might as well change it like 50. Spider-Man, Whoa, Spider-Man. Alright, so we can actually jump. Isn't that amazing? I like it. I definitely like it. Whoa! Spider-Man, Spider-Man. Alright, we can do some creepy, badass Spider-Man stuff. No! No! But the collision with the roof seems to be working just fine. So that seems to be awesome. Something that we can do as well with the falling here is that we could do +2 and -2, and this is gonna, yeah, he's gonna keep falling there, and same with the other one. So we actually can't do ninja jumps now, or we shouldn't be able to. So yeah, we did some jumping. Oh yeah, and last thing then, the hitting the head doesn't seem to make any sense at all. So we will have to do this. There we go. So that should make perfect sense. He should not be able should be able to jump even when standing next to a wall. We should be able to walk over here and do this with no ninja jumps. So actually we're gonna do one last thing, because I'm getting quite annoyed with in the fact of having to have these like little strange ticking movements here. So what we can do is we can do a little extra code for this. We can put here public static int move from border, and we're gonna set this to 500 or something like that. And about this 500 here is that actually 1000, and we're gonna do for everything in here when we're defining objects. For example, with the level here, we want to do plus component dot move from border plus component dot move from border here. Same with the character. Actually, wait a second. I have an idea. Component dot sx sy cast it into integers. Like that. We could just put this above there. Move from border. There we go. Same thing there. Move from border. And then you can see we're not going to have the character there. Exactly. And because we haven't added that to the character as well. So we have to do the set bounds here. And for the set bounds, we'll have to do plus component dot sx plus component dot sy. And I want to run it. We've got the character here, and as you can see, we just removed the randomness. Oh, he's not colliding with walls. Nah. All right, let's remove those for now, and let me just have a short thinking for the next tutorial. Oh wait, that makes sense. Why? No, it doesn't make any sense at all, actually. This should be minus there. Oh yeah, it's there. Let's just remove them for now. Let's have this little this little problem for now. We can fix this bug later. So yeah, that's actually it for this tutorial. And in the next tutorial, we're gonna first of all start out and fix this little thing. I'm just gonna have short thinking while waiting for this, or while you guys are watching this tutorial. And so in the next tutorial, we're also gonna try to cover some basic world generation tactics and destroying and placing blocks. So that's actually that, people or guys. And in the next tutorial, as I said before, we're gonna do all that good stuff. And don't forget to subscribe if you enjoyed this tutorial and favorize this video. I would be more than happy if you favorized it. At least like it and put a comment saying. If you have any problems, you can make comments. Actually, it's a better way for me to see problems is to send me a message. So please send me a message if you have any problems with this. And don't forget to check out my website. I should have all of my tutorials there as well when you're watching this. Actually, I might not, but I should. You should be from the future. You are the future, man, or you might be. So thank you guys for watching, and I'll see you again next time. Thank you guys for watching, and I'll see you again next time. Oh wait, I just said that. Right. Goodbye.